Hi guys, this is your next video lesson. It's on section 4.3 in your text. I hope you did really well on your test, and I'm going to show you two more distributions. One is called the geometric distribution and one's called the Poisson distribution. And here's the difference between the two of them. The definitions are found on page 216 in the blue boxes, which you should read very, very carefully and over again if you have to. When you do your homework, they mix in some probability, binomial distributions in here as well, so be careful. Sometimes the hardest part is figuring out which distribution is being used. But if you look at the geometric distribution, what this does is it asks the question, if I have a certain probability of something happening, and I do this thing over and over again, this trial is repeated, what's the probability of getting a success or a failure on a particular trial? So look at this question. It says a study found that smartphones made by a certain manufacturer had a failure rate of 43%. So that would give me that P is 0.43. You have to remember that P, even though we call it a success, is not always a good thing. I mean, you might be wanting to find the probability that someone has cancer. That's not a success, but yet we call it P because that's the thing that we're interested in. So a failed smartphone is 43%, which is outrageous, really. But 4 smartphones made by this manufacturer selected at random, find the probability that the 4th smartphone is the first one to have a failure. That's what a geometric distribution looks like. On what number trial are we going to get what we want, the success or failure? What's the probability of something happen on the 4th try or the 5th try or the 10th try? A Poisson distribution, on the other hand, it always gives you an average. And here's what a Poisson question will look like. The mean number of accidents per month at a certain intersection is 3. What's the probability that any given month 4 accidents will happen at that intersection? That's what a Poisson distribution looks like. So they're saying, hey, there's an average of 3 accidents per month. What's the probability that 4 accidents will happen at that intersection? So they're two different types of questions. Where the binomial says, what's the probability of having this many successes, 10 successes or 15 successes or no successes? Totally different kind of question. Watch this video over and over again if you have to. Let's do 2 questions in the homework, one of each type. So we're going to try number 12, which is on page 220. And if you're following along in your book, read it with me. It says an auto parts seller finds that 1 in every 100 parts sold is defective. Oh, so that must be my P. This is what we're interested in. That 1 out of 100. If P is 1 out of 100, then Q has to be 99 out of 100 because P and Q always have to add up to 1. Doesn't that make sense? Just like in the chapter before. And the question then says, for number 14, find the probability that the number of number 12. Find the probability that the first defective part is the 10th part that's sold. So you're choosing parts, and you want to find out what's the probability that the 10th one is actually the one that's bad. So our notation says P of X equals 10. That's what we're interested in. And we're using this formula right here where P is 1 over 100. That capital P is probability, right? P is the percentage of success, the chance of success. Q would be 99 over 100. This would be X minus 1. In our case, it would be 9, which makes perfect sense because we want 1 success and the other 9 we want to be failures. So we want failure, 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 failure 9 times, and all of a sudden we want to hit a success on the 10th one. If we did this, if you did this in your calculator and practice this, the answer comes out to be less than 1%, 0.9%. Part B to the question says, what's the probability that you get one of these bad auto parts on the 1st, 2nd, or 3rd tries? And remember that OR implies addition, so we want the probability of 1 plus probability of 2 plus probability of 3. We would do this formula 3 times over and over again, and we get about 47% chance that one of the first 3 is going to have that bad auto part. That's what a geometric distribution looks like. Let's look at a Poisson distribution, which is like number 14 in the homework. Number 14 says that a newspaper finds that the mean number of typographical errors per page is 4. So this one's telling you what the average is. It's 4. And then they say find the probability that the number of typographical errors found on a given page is exactly 3. Oh, that's my X. This formula uses the number E. The number E, which is this number, 2.718281828. It's like, this number is like pi. It's a what we call a transcendental number. If we were in school, I'd give you a whole spiel on where that number came from. But let's just use it for now. So I'm putting my numbers in. They told me the average, mu, is 4. E to the minus average, which is minus 4, over x, which is 3, and this is a factorial. What factorial means is 3 times 2 times 1. For example, like 8 factorial would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now sometimes if the number's bigger like this, we don't want to do this out, so there's got to be a button on the calculator that does this exclamation point for us. Let's look at our calculator and see how that works. I'm going to put this formula in the calculator. I hope you can see what I'm doing here. But I'm going to go, to do this, I'm going to go 4 times E, and this is where I find my E. It's second ln. It's behind the ln button. And the calculator is then going to say E to the what? And you have to tell it. We're dealing with negative 4. Don't put minus 4. It's negative 4. Close the parentheses. So I have it looking like this. Just like my formula so far. And then I'm going to go divide it by. Now 3 factorial is easy because it actually comes out to be 6. 3 times 2 times 1. But we'll just do it with our calculator because if it was a bigger number, you wouldn't want to multiply that out. We'll go to math. Go over to probability by using this arrow button. We're going to go down to number 4, which is the factorial button. And we'll hit factorial. Oh, I didn't even put a number in there. So we're going to go 3. Again, we're going to go to math right there. Go over to probability. And go down to the number 4 and hit enter. If we hit enter again, we get a point, what is that, 0.0122? So there's about a 1% chance of that happening if the average was 4, it coming out to be 3 in this situation. It would be a pretty slim chance of that happening. These are the 2 types of distributions. Make sure you read up on them. And for homework, try, what should we do? Well, let's try on page 220. And again, you don't have to do any others except for the ones that I tell you. We're going to do like number 11 to 26. Do as many as you can. Don't forget, there's geometric ones in here. There's Poisson. It's French. It looks like poison, but it's Poisson. And but they threw a couple binomials in there too, I think, to throw you off. I can maybe take a picture, although my phone's having problems sending pictures. I'll take a picture of the answers even so you can see the even ones as well. Do the odd ones first, and then work on the evens. And then be ready for a quiz next, what is it for you guys? Tuesday, right? Same time as when our class starts. And good luck, work hard, ask me questions. I'll talk to you soon. Bye-bye.